Hello, this is the second video in this series. In this video, we'll learn about Arduino. Let us examine what is happening in the first GIF. It is a relay in which bulb is turned on and off for a certain interval of time. In the second one, there are 6 different LEDs which are first glowing one after another and then all are glowing and turning off automatically. We can code and alternate the power supply which will go to the LEDs with the help of an IDE called as Arduino IDE, in which we can code microcontrollers like Arduino Uno, NodeMCU, etc. So without getting late, let's start this video. Let us first know the difference between a microcontroller and a microprocessor. A microcontroller is a small computer on a single metal oxide semiconductor integrated circuit chip. A microprocessor is a computer processor where the data processing, logic and control is included on a single integrated circuit or a small number of integrated circuits. Microprocessor consists of only a central processing unit, whereas a microcontroller contains a CPU, memory, input-output, all integrated into one chip. Microprocessor uses an external bus to interface to RAM, ROM, and other peripherals. On the other hand, microcontroller uses an internal controlling bus. Hence, an Arduino is a microcontroller which has an 80 mega 328p microcontroller general purpose input-output pins. Using Arduino, we can do many things and we will do a few projects in this course. So those are the specifications of an Arduino. The memory, it has the flash memory which is 32 KB, the SRAM which is 2 KB, the EEPROM that is 1 KB. KB stands for kilobits. The special functions are the serial and the UART, the external interrupts, the PWM that is pulse width modulation, the SPI serial peripheral interface, and the AREF analog reference. So Arduino is one of the key microcontrollers which helps us to take data from sensors, manipulate them and send them to cloud and even create some cool projects and applications, and hence it touches all the layers of the World Forum Reference Model. So this is how an Arduino Uno look like. Let me explain all the pins. Coming from top left corner, it is the slot where we can give 12 volt DC input. Moving towards the right, it is the USB Type B port using which we can connect Arduino and computer. Then comes the reset button using which we can reset the dumped code. Then you can see two slots called SEL, the serial clock, and SDA, the serial data, which are used when we want to transmit data using the I2C, that is Inter-Integrated Circuit Protocol, which is one of the protocol used to transfer data. You can see two pins which are AREF, that is analog reference voltage, and ground, which are used in designing the voltage part in circuits. There are 13 different digital pins which are used as input-output digital pins that are used to send and or receive data. There is a built-in LED for 13th pin, that is, if the input or output of pin 13 is high, the LED is turned on and it will be turned off if pin 13's value is not high, that is low. Pins 10, 11, 12, 13 are used as slave select, master out slave in, master in slave out, and serial clock, which are the four main components of the SPI, that is Serial Peripheral Interface Protocol. Pins 0 and 1 are used as RX receiver and TX transmitter that are used to transmit data. You can see the note here, that is all the PWM pulse width modulation pins are denoted with the symbol tilde. Pulse width modulation is the process in which we modify the width of the pulse so that the final power will alter. For example, if we want an LED to glow fully, we give 100% pulse width and we can decrease that to 90, 80 and so on even to 1% to make the LED dimmer and dimmer. That is the use of PWM. In the bottom part of the Arduino, you can see some pins which are used to program the AT-MEGA328 microcontroller and whose explanation is beyond the scope of this program. In the left, you can see 6 analog pins ranging from A0 to A5. It is used for analog values data transmission. It is used for analog values data transmission. A4 and A5 are used as data and clock pins. Above analog pins, there are 8 pins which are used for voltage connections. Not connected pin is left away. IO ref pin is used to set the reference voltage according to the input voltage given and a reset slot. There are two different output voltage slots, that is 3.3 volt and 5 volt. There are sensors which use 3.3 volt and some which require 5 volt as DC input voltage. So we can use voltages according to the requirement. There are two different pins for ground, same output, but there are two because generally we use ground more, so we can extend the circuit according to our convenience. You will understand it once we do a project. And finally, the V-in pin, which is used as input voltage pin. Let us know how Arduino is related to IoT. Arduino can actually be placed in the second layer of the World Forum Reference Model. As discussed previously, Arduino has two major types of pins, that is analog and digital pins, which are used to take data from sensors and analyze them. We can also connect two sensors directly and or indirectly using Arduino. So Arduino best fits in the second layer of the IoT World Forum Reference Model. This is the end of the second video. In the next video, we will know about NodeMCU. Thank you.